Everyone, welcome to our pre-lab for our Precipitation Lab. We have on the screen here an example of precipitation reaction. We have lead nitrate, an aqueous solution of lead nitrate being poured into an aqueous solution of potassium iodide. The precipitate is this yellow powder that's sinking as soon as the two mix together here. And the supernate is the liquid that is around here. Eventually this precipitate will settle, and you'd have the precipitate down on the bottom here, and the clear supernate liquid at the top. Here's another diagram of this reaction, this time with potassium iodide. We have a beaker of potassium iodide that we're pouring into a beaker of lead nitrate. When they touch each other at the interface, we immediately get a precipitate. And eventually we give this some time and the precipitate settles to the bottom, and we're given a clear supernate solution here at the top. Precipitate, it's an insoluble solid that separates from a solution. We have an aqueous solution. This is the third time we've seen it now. And we form a precipitate. That's the solid that precipitates from the solution. It forms and it drops to the bottom of the solution. And in the supernate, we have some dissolved ionic compounds. We're left at the end of this reaction with some dissolved sodium nitrate that's in this solution. What's given here on the top, this is the molecular equation, which you may or may not have talked about in your lecture class yet. We can take this and write it out as the complete ionic equation, where we take everything that's in an aqueous state, and we remind ourselves that each one of these are actually separated when this substance is dissolved. So we have a lead 2, we have 2 nitrates, we have 2 sodiums, we have 2 iodides on the left-hand side of the reaction. We form the precipitate, which is together, it's a solid. And then the sodium nitrate is aqueous, so we have 2 sodiums and 2 nitrates on the right-hand side of the equation. We can go in the same way we can with algebra. We can go in and cancel anything that's present on both sides of the arrow. So nitrate is present here and here. So we put a line through it, we cancel it out. Sodium is here and here, cancel, cancel. And we're left with our net ionic equation. That one lead gets together with 2 iodides to precipitate as lead 2 iodide. Sodium and nitrate are left as spectator ions, and they're in the supernate part of the solution. If we wanted to get rid of those, we could decant off the supernate, wash the precipitate a few times with water, and eventually be left with pure lead 2 iodide. We can also, for these, we already saw a bit of this, we can have color changes that occur. In this example, we have a clear solution of silver nitrate reacting with a yellowish solution of sodium chromate to give us a red solution of silver chromate that precipitates out here. This is mixed together, it's been given time, it settles as a precipitate at the bottom. Precipitate is the solid that forms from a precipitation reaction, which happens when 2 aqueous solutions of 2 different reactants are mixed. Here's an example. This can be used to test for chloride, and in this example we're taking seawater, which has a lot of sodium chloride in it. We add in a bit of silver nitrate. Silver nitrate will precipitate out and precipitate out as a solid. We can go back and actually weigh the amount of silver chloride that is produced and figure out the amount of chloride that was in this initial solution. We're probably not quite ready to do this in class, but this is something you'll do later. There can be a couple steps that happen with a precipitation reaction. So we've got a solution here, maybe our salt water again. We add in a silver nitrate reagent, and we see the beginning of a precipitation. But what actually can precede full precipitation is suspension. And this is just that these particles just aren't quite dense enough to precipitate out yet. And so we get this suspension, and all we have to do usually to get a suspension to turn into precipitate is wait. So we wait on the suspension, and eventually the majority or all of the suspension will come down as a precipitate, and eventually hopefully we get a clear supernate solution. Here's an example of that, a real example. We have this suspension here on the left, and it was timed, and after about 15 minutes you see that the majority of this material settles to the bottom and ends up as a precipitate, and the supernatant solution clears. Given enough time, this would go completely clear. All right, here's some tips and tricks for the lab. If something is marked with an L in parentheses, it's a liquid and a pure substance. Aqueous is written as AQ and is a compound dissolved in water. S is a solid and is a compound that isn't soluble in water. As you do the lab, you want to look for cloudiness and or color changes to identify precipitate formation. Aqueous solutions are see-through. And a really good way to do this is when you guys are in the lab, if you can't tell, is to go to a window and look at transmitted light through the solution. If you look to the outside light through the window, it's often easy to see if you have, in fact, a suspension that's going to settle down into a precipitate. For the ions in solution column, as you're writing up the lab, split the ionic compounds up into ions that they are made from. For example, split sodium phosphate into sodium plus and phosphate 3 minus. Circle the ions in the ions in solution column that you think will precipitate based on the solubility rules. Use the reaction in row 1. We will use the reaction in row 1 to show you how you can use the ions in solution column and solubility rules to directly write the net ionic equation. Here's some more tips for the lab. The test tube rack will be in one of the drawers. The tiny test tubes that you'll need, however, will be in a bin near the balance. Use a pipe cleaner to thoroughly wash the test tubes. If you have traces of materials from previous experiments, it can really make this lab much more complicated. So you want to take your time, wash out the test tubes, and rinse them well with the deionized water. Students should check that the precipitate formulas are correct with their lab instructor. You can check with the person in the lab, you can check with me as I pass through. Before you turn in your lab report, you should check those with us. Also, as far as running of the lab, your lab instructor will assign your group to start with the reaction in row 1 or row 5 or row 9, and this is just so that everyone isn't waiting for the same reagents. So you'll start with whatever row you're given and move down the table. And then, for example, if you were given 9, you would go all the way to the bottom and then start back at 1 and come down. And this is just to make it more manageable as far as the reagents. People aren't using the same ones. As far as safety, you must wear goggles and lab coat the whole time while any chemicals or equipment is being used in the lab room. You can take a break in the hallway from wearing goggles if you need to. Goggles are worn over the eyes, not on foreheads or chins, and use paper towels to absorb any reagents that are spilled on the tabletop. Cleanup and waste disposal. Make sure to dispose of your samples in the appropriate waste jug. If the waste jug is nearly full, please notify your lab instructor so they can ask for a new one. Please don't overfill the waste jug. That'll cause it to flood the hood and make a huge mess for you and your lab instructor. When you're cleaning up, rinse your tiny test tubes and return to the correct location. Return the pipe cleaner to the beaker that will be near the balance. Use the cleaner that's available in the room to wipe down the surfaces of your workstation.